Hello everyone, in today's class we're going to deal with trigonometric ratios of special angles. So I'll be teaching more than what we have in this textbook, so please pay more attention to what I'm going to do. So now I will start from the beginning and explain everything step by step, so that at the end of this class what we are going to achieve is that you are going to be able to solve for sine, cosine and tan of an angle without using your calculator, especially for special angles. So pay very close attention to this class. So let's assume this is an equilateral triangle. I know I didn't draw it up to scale, but what equilateral triangle means is that all sides are equal and all angles are equal. It means that here is equal to here and equal to here, and this angle is equal to this angle and equal to this angle. So we all know that the total angle of a triangle is 480 degrees. So if all angles are equal, they have three angles. So it means that here is 60 degrees, here too is 60 degrees, and this total place is 60 degrees. But because I divided it equally, I'll give here 30 degrees and give here 30 degrees, so it will be equal to 60 degrees. Now what is the angle here? We all know that any straight line that has a perpendicular line on top of it, according to the angle rules, means that the angle there is 90 degrees. So here is 90 degrees and this is sine for 90 degrees, so we're not going to write it out. So we've gotten the angle of this triangle. Next, the sides. Let's assume here is 2, so it's easy for us for the calculation, and here is 2. From here to here is 2. Since it's an equilateral triangle, it means that all sides are equal. All angles are equal. This is a sign to make sure that to tell that this is what is supposed here. This is what we do. So here 2 will be 2, but because I'm dividing it into 2, mind you, my drawing is not up to scale. As you can see, here is obviously longer than here. But what we are trying to achieve is everything. This is divided into 2. So here will be 1. Here will also be 1. Now, the next thing we are going to find is the length of this side. Let me call here A. That is this line here. Call here B. And call here C. Now, to find the length of this line, this perpendicular line, we are going to use the Pythagoras theorem, which states that the square of the hypotenuse is equal to the square of the two sides. How do you know which one is the hypotenuse? Hypotenuse is the one facing the 90 degree. So here is the hypotenuse. So, and Pythagoras theorem, we all know that only applies to a right angle triangle. Since we draw a perpendicular line to this triangle here, dividing this equilateral triangle, this triangle we have here is now a right angle triangle since it has 90 degrees. Right angle triangle is a triangle that has 90 degrees in it. So just taking it step by step, so we will not miss any point. So meaning that a square will be equal to a square is equal to b square plus c square. What is a square? A square is 2. Square is equal to, what is b square? B square is 1 plus c square. C square is what we are looking for, so I will still leave it as c square. So if I rewrite this, I will have 1 square plus c square is equal to 2 square. So 1 square is 1, c square is c square, while 2 square is 4. So by the time I subtract 1 from here and from here, I will have c square equal to 4 minus 1. Because when I subtract 1 from here, 1 would go. When I subtract 1 from here, you still have 1. So c square is equal to 3. So I find the square root of both sides. Square root of c square is equal to square root of 3. Hope you are following up. So square root of c square is c. Square root of any square of any number is that number. It's like you say square root of which number will I use? Say square root of x square to give you x. So when you find the square root of any the square of any number, it will give you that number. So square root of c squared is c, and we are now left with. So this place is now root 3. So if I am to extract this triangle, because this is what we need, I've already proven how we got it. I will have something like this. I'll have root 3 here. I'll have 1 here. I'll have 2 here. I'll have 30 degrees here. I'll have 60 degrees here. And I'll have a right angle triangle. So this is what we need to get, because look at what we are looking for. 90, 60, and 30. That's where we are starting from, the first quadrant. I'll explain what we mean by the quadrant. So I'll explain what we mean by quadrant when we want to go for the higher angles. For now, we are in the first angle. So let's focus on that. So now, what is sine? Sine simply means opposite all divided by hypotenuse. That's sine. Then what is cos? Cos simply means adjacent. I'm getting the spelling correct. All divided by hypotenuse. Then this hypotenuse has E here. Then what is tan? Tan, the definition of tan is it's supposed to be opposite over adjacent. Another way you can define tan is sine over cos. So this is cosine. This is the real name of this is tangent, but we'll call it tan. We've been using tan for the cause of this one is cosine, but we're using cos as the short form as we go through this class. So we're using cos. I think this view is better. So how were we able, because I want to be showing explanation of everything we arrive at, how were we able to assume that tan is as same as sine over cos? Now let's look at it. Let me use O for opposite, and let me say O. Going forward, I will not stop writing the full name. Let me say O is opposite, A is adjacent, and H stands for hypotenuse. Now let's say sine obviously is O over H, and cos is A over H, while tan is O over E, right? So if we are to solve sine over cos, we are going to get O over H divided by A over H. So we all know that when you want to divide a fraction, you change this sign to multiplication and inverse the division side of it. So O over H multiplied by, because I've changed this to multiplication sign, it's no longer division sign, it will now be H over E. That's it, how to divide a fraction. So if you notice, this H and this H will cancel each other, and you have O over E, which is the same thing as tan. So tan is also sine over cos. Please be taking note of all this, because when we start solving, you will know why we are doing this. So the shortest formula we need to remember it. We need to remember it as students is, we'll call it so. Call it so Sorry, this is H. K. Toi. Is the easiest way. If you are having issue trying to remember that sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. So ka toi. So this is opposite over hypotenuse. Ka, this is adjacent over hypotenuse. Toi, this is opposite over adjacent. So you can just highlight this and store it in your memory. Now let's start solving for the sines of these angles. Now sine of 60 degree, sine 60 degrees. Please, what is opposite? Opposite is the side facing the angle. So that sometimes maybe I say let me solve the first one. Opposite is the side, any side that is facing the angle is opposite. While the adjacent is the side the angle is sitting on. As you can see, this 60 degree is sitting on this angle. We all know that adjacent is just any side that is facing 90 degrees is hypotenuse is the side that is facing 90 degrees. So sine 60 will be the one facing this 60 degrees is root 3, while the hypotenuse that is 2. So this is the answer for sine 60. Since there is no root under here, this surd is okay. We all remember when we are doing surd, we always want to remove any root on the denominator. Now when we are being told, let's say let's find sine 30 degrees. So take note of this. Let's find sine 30 degrees. Now, you know why I explained that formatting? Now I say sine 30 degrees. For those that don't understand, they might say, oh, this is the opposite. Since we use the opposite for 60 degrees, why are we no longer using it here? That's why I have to explain it earlier. So this is 30 degrees. The side facing it is 1, not root 3. So the opposite of 30 degrees is 1 over hypotenuse, which is 1 over 2. Take note of this. The next thing we are going to find is sine 90 degrees. Sine 90 degrees. We all know that this 90 degrees is already facing hypotenuse. So there's no how we can say opposite over hypotenuse. It's already facing hypotenuse. Do we get it? So just know that sine 90 is 1. You just have to know this. Though, if you can, I don't know if logically, you say that this is hypotenuse facing hypotenuse, which is, sorry for that. This is hypotenuse facing hypotenuse, which is 2. You can say 2 over 2, she's still giving you 1. But logically, I don't know if that applies, but sine 90 is 1. So we are done for sine. Let's go to cosines. Let's go to cosine or cos. Cos 60 will now be equal to, this is 60. Remember, cos is adjacent over hypotenuse. So this is the adjacent, the number, the where the angle is sitting on, the tangent to that angle, which is 1. The hypotenuse is 2. So cos 60 is 1 over 2. Take note of this. The next is cos 30. Now this is 30. For those that will say, why are you not using 1 here? 1 is opposite to 30. So the tangent, which is the adjacent, is root 3 over hypotenuse, which is root 3 over 2. Take note of this. The next is cos 30. Cos 90, I mean to say. So cos 90 is 0 degrees, or just 0. So just note it that cos 90 is 0. Another thing you need to know when you are dealing with these special angles in a quadrant, you understand? If you sum, well, let's not go to that side here. Let me just leave it. So cos 90 is 0. This is 90. You don't even know which of them is the adjacent. Here is adjacent, here is the adjacent. So just know that it's 0. It's not something we'll start proving in this. It's not something we'll prove in this class. The next thing we are going to look at is cos 0 and sine 0. Okay, let me put it here. Cos 0. Just know that cos 0 is 1 and sine 0 is 0. So let's summarize what we just did. For sine, we have sine 30 degrees to be, from what we solved, 1 over 2. Sine 60 degrees to be root 3 over 2. Sine 90 degrees to be 1. I think I'll write sine 0 here to be 0. While for cos, we have cos 0 degrees to be 1. Cos 30 degrees to be root 3 over 2. Sine 60 degrees to be, sorry, what am I doing? Cos 60 degrees to be 1 over 2, while cos 90 degrees is 0. So the next one we are going to look at is tangent. And we know that tangent is adjacent over, so opposite over adjacent, which we can also use our triangle here to find that cos 60, tan 60 will be opposite, which is root 3 over 1. Tan 30 will be opposite, which is 1 over root 3. Same thing applies to here. But I'll prefer to use the other formula that I showed you here, that tan is sine over cos. There's a reason why I want to do that, because of when I get to tan 90 and tan 0, it explains it better. So let's go to tan. Now, tan 0 will be equal to sine 0 over cos 0. Now, sine 0 is what? 0. While cos 0 is what? 1. So tan 0 is 0. The next is tan 30. Tan 30 is 30 degrees is sine 30 over cos 30. Which should give us tan 30 is 1 over 2, while cos 30 is root 3 over 2. This is equal to 1 over 2 times, you now change it, 2 over root 3. 2 cancel, you have 1 over root 3. But we all know that in Surds, we don't like leaving. This is the answer. In case if you see it like this in any textbook, this is still the answer. But we always prefer leaving the sign at the top. So the second answer you can also get for it is to say 1 over root 3. Remember our previous class, how to rationalize, how to remove the sort from the denominator, multiply it by root 3 over 3 by root 3 over 3. So when you do that, you get this, you don't need to cancel again. If you cancel, you get back this thing. So you have to multiply it at root 3 over 3 times root 3. And when a number multiplies itself, it gives you that number. When a root of a number multiplies itself, it gets the number. So it will be root 3 over 3. That's root 3 over 3. So when you look for tan of 30 degrees, this is the two possible answer you will get for it. If in case if you see this one, it's correct. If you see this one, it's still correct. So we'll go to tan 60 degrees, which is cos, which is sine 60 degrees all over cos 60 degrees. You have sine 60 degrees from here. We have root 3 over 2 divided by cos 60 degree 1 over 2. So which is equal to root 3 over 2 times, we now invert the number over 1 to cancel. We now have root 3. The next is tan 90. This tan 90 is the main reason why I want to use this formula and solve it. If you still use the triangle formula, you still get it. Just know that 0 and 90 are special. You just need to know the answer. The triangle explains it, but it's not what I want to cover in this class, so don't make this class too complex. So here is equal to sine 90 all over cos 90 degrees. So the answer is sine 90 is what? 1. Cos 90 is 0. Now, this is a special case in mathematics. Any number that is being divided by 0, the answer is infinity. Infinity. So any number that is being divided by 0, the answer is infinity. Take note of that. Maybe in another class we'll cover it. How any number that is divided by 0, the answer is infinity. I don't want to make this class complex. It's like, what's the closest number to 0? It's like 0.00000 to something. And if you want to divide something like that, you get a very large number. But this is not what we are going to cover in this class. So now we've gotten tan. This is tan. This is that. If you punch tan 90 in your calculator, you get something like math error because it's too large. The calculator cannot just process it. So this is the summary of what we have done so far. Tan 0 is 0, and 30 degrees is okay, is either 1 over root 3 or it's still the same. So that doesn't look like when I use or, it means that it's two different numbers. It's the same. It's or 3 over root 3. Sorry. This is root 3 over 3. What we got here? Just that this, we took away the square root from the denominator and push it up. Then tan 60, what do we get? Is root 3, while tan 90 is infinity. This is a sign for infinity. So this is the summary of what we've done so far in this class. So we've done 0 degree, 30 degree, 60 degrees, and 90 degrees. So in the next class, we are going to go further and prove other angles, mostly 45 degrees. Thank you, and see you in the next class.